Okay, so a quick reminder here before you start these prediction problems. Okay, and that reminder is this. Okay, the steps for predicting the products of a reaction. Okay, the first step is identify the type. Okay, identify the reaction type. Is it double replacement? Is it synthesis? Is it decomposition, combustion, etc.? Okay. Okay. Second step, follow the reaction pattern. Okay, to get your products. Okay, so what we mean by that is if it's a double replacement reaction, swap your metals and put the new pairs together. Okay, if it's a decomposition reaction, write the atoms separately, all of that kind of stuff. Okay, third step, check for special elements. Okay, especially in a single replacement or decomposition reaction. Okay, fourth step, drop and swap any ionic compounds. Okay, especially important in a synthesis reaction, a single replacement reaction, okay, or a double replacement reaction. And the last step, okay, balance the reaction. Okay, so those are our steps when we're predicting the products of a reaction. So I'll give you a little bit of time to get ahead of me here, and we'll go through some of those. Okay, so for number one, okay, what kind of reaction are we looking at? It's a combustion reaction. We have a hydrocarbon reacting with oxygen. Okay, so the products of a combustion reaction are always carbon dioxide and water. Right, so we've identified the type, we followed the pattern, predicted the products. Okay, there aren't any ionic compounds, so there's no dropping and swapping. There aren't any special elements to check for. Okay, so now it's on to, we have to balance the reaction. Okay, now obviously combustion reactions have special rules. Okay, the first rule is that we balance alphabetically, and the second rule is if there's an even number of carbons, I start my balancing with a 2. Right. Okay, so I'm going to put a 2 here. That's going to give me 2 times 2 is 4 carbons. So now I balance my carbons. Okay, 2 times 6 is 12 hydrogens. So I'm going to go over here and make sure I have 6 times 2 is 12 hydrogens. Okay, and then last in alphabetical order is the oxygen. Okay, I have 6 oxygens here in the water, and there are another 4 times 2 is 8 oxygens here in the carbon dioxide for a total of 14 oxygens. So 7 times 2 is 14 oxygens. Okay. Questions on number 1? Okay. How many people have done number 2? Okay, let's have a look at that one too then. All right, so in question number 2, I've got sodium nitride, which is an ionic compound because sodium's a metal and nitrogen's a non-metal. Okay, and it's reacting with magnesium, which is sitting here just as an element. Right, so what kind of reaction type are we looking at with ionic compound plus element? So it's a single replacement reaction. Okay, so now I've got to follow my pattern. In a single replacement reaction, the pattern goes that the element will replace the part of the ionic compound that is like it. Magnesium is a metal. So that means it's going to replace the sodium because sodium is acting as the metal in this ionic compound. All right, so now that I know the pattern, okay, then I know that sodium will end up by itself and magnesium is going to have a partner in nitrogen. Okay, next step is check for special elements. Okay, sodium's not special, so I have no special elements. Okay, next thing is swap and drop any ionic compounds. Well, this is an ionic compound. Magnesium has a 2+ charge, nitrogen's a -3, so I bring the 3 down here, I bring the 2 down here, and now my compound is dropped and swapped. Right? Then my last step is I need to balance the whole reaction. Right? If I just put a 3 in front of magnesium, even though that's kind of a big number, that's not really going to work. Putting a 3 in front of the sodium's also not going to work. So I need to balance the nitrogens first. Okay? So there's a 2 here beside the nitrogen on the product side. So I'm going to go back over here and make sure that I have 2 nitrogens on the reactant side. Okay? That gives me now 2 times 3 is 6 sodium, so I need to go over here and make sure that I have 6 sodium. Right? And then when I look back over here, I have 3 magnesium, so I need to go back over here and make sure I have 3 magnesium, and now my reaction is balanced. Okay? How many people have done number 3? So look at that one too then. All right, so on number 3, we have a decomposition reaction because this is just a single reactant, and that's the only kind of reaction that has a single reactant. Okay, the pattern for decomposition reactions is split it up. All right, so magnesium as an element, nitrogen as an element. All right, next step, check for special elements. Do I have any? Yes. Nitrogen is special, comes as a 2. All right. Any ionic compounds to drop and swap? Okay, so I've done that step. All right, then I have to balance the whole reaction. Nitrogen's already balanced. The only thing that's out of balance is magnesium. 3 here will balance that. Okay, I'll give you a few more minutes to get ahead.
If you accidentally, I think I might have fluked number 3, because I accidentally transferred the 3 magnesium over to the other side. I just put Mg3 plus N2. Would that still be right or not?
No, because if you write Mg3 like this, you're saying the 3 magnesium atoms are chemically bonded together, which would make magnesium a special element. It's not. Okay, this is saying a molecule, like this little 3 is saying you have a molecule of magnesium. We don't. We have 3 separate magnesium atoms. I mean, in the end, it still means the same number of atoms, but it's how they go together that makes a difference on it. All right, I'll give you a little bit of time to get ahead of me again here, and then we'll go through another 3. Okay, let's have a look at 4, 5, and 6 then. Okay, so in question number 4, okay, we've got sodium permanganate. Okay, that's what MnO4 is, so that's an ionic compound. Okay, and it's reacting with iron 2 sulfide. All right, which is also an ionic compound. So I've got 2 ionic compounds, which means this is what kind of a reaction? Double replacement. All right, so in a double replacement reaction, the pattern is switch the metals. So that means sodium is going to end up with sulfur, and iron is going to end up with permanganate. All right, so now that I've got those, check for special elements. There aren't any. Okay, now I got to drop and swap. All right, so when I'm dropping and swapping, sulfur's a -2, sodium's a +1, so this will be Na2S. Okay, iron can be a 2 or a 3. Okay, so I go back over to the reactant side, and this must be the iron with the 2+ charge because it's paired evenly with sulfur, which is -2. All right, so this is a 2+ charge. Permanganate is a -1, which means we're going to have brackets with a 2 outside for that one. Okay, how important is the drop and swap? If you don't do it, will you get it balanced? All right, so now that I've got the drops and swaps done correctly, okay, I'm going to start my balancing. I'll start with sodium because it's a 2. Okay, I'm going to go back over here and make sure I have 2 sodiums. That gives me 2 permanganates, which I have over here on the product side. Okay, 1 iron on the products, 1 in the reactants, 1 sulfur in the products, 1 sulfur in the reactants. Now the reaction is balanced. Okay. Questions on number 4? So question number 5, I've got copper as an element reacting with fluorine as an element. All right, so what kind of reaction starts with 2 elements? Synthesis reaction. Okay, so in a synthesis reaction, all I do is combine them. All right, this is a metal, so I have to write it first. Okay, and it's bonding to a non-metal, so I write that second. Now, here's a trick, something that doesn't come up very often, okay, but it comes up once in a while. Copper can be a 1 or a 2+. But over here, I can't figure out what it is because it isn't paired with anything. So what do? First charge listed. Okay, I go to my periodic table, whatever charge is listed first, so on the left, okay, that's the one I use. The most common charge for copper is 2. All right, so that happens sometimes. Okay, you just have to be aware of it. All right, so copper 2+, okay, and fluorine is a -1, so when I drop and swap this, I have CuF2, okay, and that means that my reaction then is already balanced. Okay, questions on number 5? Okay, so number 5 has that little trick that sometimes comes up with multivalent metals. All right, and then we'll do number 6 here. So in number 6, I've got hydrogen, and it's with sulfate, so that's an ionic compound, hydrogen sulfate. Okay, and then I've got magnesium hydroxide as the other ionic compound. Right, so it's a reaction containing 2 ionic compounds as reactants, meaning it is what kind of reaction? Double replacement. Okay, so in a double replacement reaction, I'm going to swap the metals. That means hydrogen will end up with hydroxide, and magnesium will end up with sulfate. Okay, so I followed the pattern. Now I need to drop and swap my ionic compounds because obviously I don't have any elements to worry about. All right, this is a -1, and this is a +1. So that one's already good because it's water. Okay, and then magnesium's a 2+, sulfate is a 2-, so that compound is already good the way it's written. Right? But I need to balance both my hydrogens and my hydroxides. They're both 2s. If I put a 2 here, that will balance them both, and now my reaction is balanced. Okay. Questions on number 6? Okay, how many people have done number 7? Okay, let's do number 7, then I'll let you guys have a little bit of time to get 8, 9, and 10 done. All right, in number 7, I have only one reactant. Okay, if I only have one reactant, then the reaction type is decomposition, and in a decomposition reaction, I simply split the elements apart. So I'll have phosphorus and oxygen. Okay, decomposition reactions always need to be checked for special elements. Both of these are special. Okay, phosphorus comes as a 4, oxygen comes as a 2. Okay, I don't have any ionic compounds to drop and swap, so that step is done. Now I need to balance the whole reaction. All right, phosphorus is already balanced, but I've got 5 oxygens over here and 2 over there. What's the lowest common multiple? 10. Okay, so I'm going to put a 2 here. That's going to give me my 10, it's going to give me 10 oxygens. So I'm going to put a 5 here to get 10 oxygens. But this 2 also means I now have 8 phosphorus. So I need to put a 2 there to make my phosphorus work, and now the reaction's balanced. Questions on that one? Okay, I'll give you a few more minutes to try the last 3 there. All right, so for 8, 9, and 10, okay, so for number 8, I've got tin as an element reacting with beryllium nitride, which is an ionic compound. Okay, so the type of reaction here is single replacement. Okay, in a single replacement reaction, the pattern goes element replaces the thing that it's like in the ionic compound. Tin is a metal, so it's going to replace beryllium. So I'm going to have tin, okay, with nitrogen, and I'm going to have beryllium by itself. All right. So now I need to check for special elements. Beryllium is not a special element, so it doesn't need a number beside it. Okay. Then I need to drop and swap this ionic compound. Nitrogen's a -3, and tin. What's tin's most common charge? 2. Okay. So I have 2 and 3 here, so I'll have a 3 on the tin and a 2 on the nitrogen. Okay. And now I need to look at balancing everything. Well, I've got 3 tin over here, so I'm going to put 3 tin over here. My nitrogens already work, and I have 3 beryllium on the reactant side. Now I have 3 beryllium on the product side. Oh, +4 is it +4 in this first? You're right. Sorry. You are right. Let's try that again. That will change several things. All right, so we got tin, which is, sorry, a 4+, okay? And it's now with nitrogen, which is a -3. So we'll have 3 tin and 4 nitrogen. Okay, like so. Okay, and now we need to balance the whole reaction. So I've got 4 nitrogen, that's the biggest number, so that's what I'm going to start with. Okay, I'm going to put a 2 here to balance that. That's going to give me 6 beryllium, so I need to get rid of this 3. Okay, and I've got 3 tin, so I need to put a 3 over there. Okay, good eye. Okay, number 9, 2 ionic compounds reacting, sodium bromide and lead 4 sulfide. Okay, how do I know it's lead 4? Well, sulfur is a -2, okay, and there are 2 of them, so that gives me 4 negative charges. That means I need to get 4 positives out of this single iron. Why am I doing that? I'm going to need to know it for the drop and swap on the other side, right? So I've got 2 ionic compounds, meaning this is a double replacement reaction. So sodium's new partner is sulfur, lead's new partner is bromine. Okay, lead's a 4+, bromine's a -1, so we got PbBr4. Okay, sulfur's a -2, sodium's a +1. Okay, so we got Na2S. So now we've dropped and swapped. There aren't any special elements. Okay, now I just need to balance the reaction. So looking here, probably better balance my bromines first. Okay, I've got 4 over there, so I'm going to put 4 over here. That's going to give me 4 sodium, so I need to put a 2 here to balance that. That makes my sulfur work. Okay, and I've got 1 lead and 1 lead, so now everything is balanced. Okay, questions on number 9? All right. So for question number 10 then, I've got sulfur reacting with calcium, both elements. Okay, so this is what kind of a reaction? It's a synthesis reaction. What kind of compound am I going to make? Ionic or molecular? I'm going to make an ionic compound, which means I have to write the calcium first. Metal first, non-metal second. Okay, there's that trick again. It's the only one I have. I'm going to play it every time. Okay, so calcium is going to end up with sulfur. Okay, sulfur's a -2, calcium's a +2, so that's dropped and swapped. There aren't any special elements to watch for. Okay, now I need to balance the whole reaction. 8 sulfur over here, so I need an 8 in front of that, and an 8 in front of that to make it work. Okay, how are we feeling about this prediction stuff? Feeling a little better about it than last week? You guys seem to have smiles on your faces a little more often. Or at least you don't look angry. All right, I'm going to give you guys a little break here, give you about 3-4 minutes here. If you need to go to the bathroom or get a drink, okay, then come back and we'll have some more stuff to do here. All right, so for number 1 here, right, we've got potassium reacting with water. All right, what kind of reaction are we looking at there? Single replacement, yeah. Okay. Now I know that's weird because water is not really an ionic compound, but it's written as one here. Okay, so K is our metal and our element, so it's going to replace the metal in hydrogen hydroxide, so that'll be hydrogen. Okay, so what we're going to have is hydrogen gas by itself and potassium with hydroxide. Okay, hydrogen special, which is why it's got the 2 beside it. Okay, and we got to drop and swap our potassium hydroxide. This is a -1, that's a +1, so that one's already good the way it's written. And then we just have to balance. So I'm going to need to put a 2 here to balance my hydrogens. And then we have to go over here, put a 2 to balance my hydroxides. That gives me 2 potassium. So I'm going to go back over to the reactants and put a 2 in front of the potassium. Okay. All right. Question number 2, we've got copper 1 sulfide, okay, and I know it's copper 1 because sulfide's always a -2, okay, and there's 2 coppers here, so they must be +1 each, okay, and then that's reacting with sodium hydroxide. That's a double replacement reaction, so I'm going to swap the metals, okay, so Cu will end up with OH, and sodium will end up with sulfide. Okay, sulfide's a -2, sodium is a +1, so we're looking at Na2S. Hydroxide's a -1, and we just figured out that copper's a +1 in this case. Okay, so that means that means no brackets. That means this is already good the way it was written before I messed it up. Okay, CuOH. And then we have to balance this. There's 2 copper on this side, so I need to put a 2 here. That's going to give me 2 hydroxides, so I've got to go back over to the reactants and make 2 hydroxides. That gives me 2 sodium. There's 2 sodium over here in the products, 1 sulfur, 1 sulfur. Equation is balanced. Okay. All right, and then for number 3, iron as an element reacting with oxygen as an element. Okay, so 2 elements reacting together is a synthesis reaction. The pattern for a synthesis reaction is put the 2 elements together in a compound. This will make an ionic compound, so iron gets listed first. Okay, now we got to go back again to this whole multivalent metals thing, okay? I don't know what charge iron has. There's no way for me to figure it out from a drop and swap, so I have to go with the most common charge, which is, right, 2? 2 was the first. Okay, so iron with the 2+ charge, okay? Oxygen with the 2- charge, so that product is already good the way it's written, okay? I just need to balance my oxygens and then my irons. 3 is listed first? You guys keep giving me bad advice here. Okay, so 3 is listed first. +3, -2. Okay, so we'll have Fe2O3. Okay, and that means this has to be a 2. Okay, to give me 6 oxygens and 4 irons. Okay. All right. So tomorrow you will have a quiz with likely 5 prediction questions on it. I will post some questions like that after school today. Make sure you check that out tonight. Okay.